Dear colleagues, let me present the topic of our research, visualizing the school organic chemistry course with augmented reality. A successful modern person has to possess such qualities as creative, analytical, innovation thinking, the team project work abilities, information literacy, and effective information and communication technology skills. STEM education has become vitally important. The main advantage of it is the complex integration of interdisciplinary approach units with the project study that combines natural sciences with technology and engineering. Natural sciences are mostly experimental. Memorizing natural science knowledge effectively depends not only on the theory supply form, but also from realizing the experimental part, which require proper theoretic training both for the teacher and for the student. Digital era, especially nowadays during the war in our country and under the national pandemic circumstances, the whole study is fully or partially remote. In this case, information and communication technologies are critical, considering the fact that the main study tool for a present-day student is not a personal computer or a laptop, but a cell phone. The school chemistry course provides visualization of molecules in 3D. As far as the AR technology is multifunctional, it plays video files, audio files, images, 3D models. Its appliance within the school chemistry course is pretty wide. That's why AR technology must be combined with the study content, which will include the text data as well in the perceptible for the modern age student's grade. The new era student needs not so much knowledge, but what they do need is to think consequently and critically. They need the intellectual activity. When the students themselves cooperate with the object studied, they investigate the environment in a better way. That is why, while working with students, practical methods should be prioritized. One of the perspective approaches which expedites solving this problem is lab booking. What is a lab book? Lab book is a multifunctional folder that contains buckets and mounts for a variety of didactic material. This type of project is universal. It can be developed from any topic to any subject. It promotes the development of creativity, imagination, can be used simultaneously by a group of students, and has its didactic properties. Making a lab book allows to find work for each student in the team. Someone comes up with a concept, someone looks for information, someone is engaged in design, someone expresses its public speaking skills and presents the results of work to the class. Creating a lab book helps capture and classify the learned material, and overviewing it allows to refresh the completed subjects pretty quick. That is also a good way to replay the learned info. The objective of our research is developing a lab book designed for studying carbohydrates according to the 10th grade chemistry program with augmented reality and investigating its efficiency while studying organic chemistry. It includes the theories, tasks, and image markers for the mobile app with augmented reality. The developed lab book provides the information according to the 10th grade chemistry program, includes formula and molecular structures of glucose, fructose, sucrose, starch, and cellulose, nutrition value of carbohydrates, carbohydrates in food products, their impact on the human body, methods of production and refining of sucrose from different stock material, nutrition products containing sugar, and interesting facts about carbohydrates. A free mobile application, LiCo.STEAM Sugar, powered by Android, was developed in order to visualize the chemical structure of carbohydrates and reproduce the laboratory experiment videos, which can be used both by the teacher and by the students to study the carbohydrates topic. Augmented reality markers designed for the AR technology were developed on the Vuforia platform. 3D objects were modeled with the 3D Max app. Augmented reality objects were realized with multi-platform tool designed for developing 2 and 3-dimensional mobile application Unity 3D. The 3D pictures of molecules of carbohydrates, learning which is required by the study program, give the opportunity to visualize the molecules of glucose, fructose, sucrose to the max point, make them alive, develop and boost the student's spatial intelligence, and to give a deeper understanding of the study data received by air, which will boost its memorizing and building specific practical skills. This method has much more advantages comparing to computer programs as far as it gives the opportunity to visualize the lab book images no matter where the student is located, in class, during the city sightseeing, at home, etc., on the cell phone, and it does not require a computer or a laptop. And what about experiments? We can solve this problem too. Simple and safe experiments on the topic that can be performed at home were selected. For the purpose of building practical skills while studying this topic, students can perform the following experiments: analyzing the starch concentration of nutritive products, investigating starch concentration in cereal crops, identifying carbohydrates. Video data of laboratory experiments were created for the purpose of supplying the experimental part. The developed video are displayed on a phone screen after connecting them with individual marker images in the lab book. The figure on the slide gives an example of one of the developed markers for the recommended laboratory experiments on the carbohydrates topic, located in the lab book. Also, the lab book Carbohydrates provides the setup of industrial production of sugar from sugar beet, which every student can overview in AR. When the cell phone or tablet is pointed on the particular marker, an animation video is displayed on the screen. An example we can see on the screen now. In order to identify the curiosity of 10th grade students in using the augmented reality and its efficiency during the chemistry lesson, students of high school number 24 in Ivano-Frankivsk city took a survey. The survey was taken by 60 people. The survey results show that each student has a personal mobile device that can be used for a study, and all the students have used mobile apps with AR within the study process, and 100% of surveyed have confirmed the advantages and the technology's benefit during the chemistry lessons. Furthermore, 83.87% of the surveyed think these technologies would be efficient during other lessons. The survey results picture is shown on figure. The students using the lab book Carbohydrates integrated with the mobile app LiCo.STEAM Sugar while studying the theory had higher results, which is confirmed with the increase of education achievement rates. The calculation results are given in the table. So we can make the conclusion that providing mobile education technologies not only lift study to a new level, supplying the users access to knowledge 24 hours a day with no matter where they are, but also give wide opportunities for the students. In the cooperation with AR, Labbook is an interesting interactive tool of study, which makes the teacher's work easier, visualizes the theories in good quality, and boosts the student's perception level. Thank you for your attention. Take care.